Ever looked around and wondered what everything is made up of? The trees, the sun, and even yourself. Let's try to understand this by having a look at atoms, elements, and compounds. Let's then look at how chemists represent chemical reactions in writing and what's really happening during these reactions. So way back in the 1800s, a scientist called John Dalton thought about what everything is made up of and came up with a theory. He proposed that everything is made up of tiny particles called atoms. These particles are so small that you can't even see them under a microscope. We can imagine atoms as being little spheres. Everything in this world is made up of these atoms. They can never be broken down into pieces or destroyed. Lots of identical atoms come together and form elements. All of the atoms in an element are identical to each other and different to the atoms in another element. And when two or more different types of atoms join together, they form compounds. This is known as the Dalton atomic theory. So let's take a look at how water is formed. When two hydrogen atoms and one oxygen atom combine, they form a compound called H2O, or better known as water. Every element is given its own unique chemical symbol, such as H for hydrogen and O for oxygen. The chemical symbol for every element can be found in the periodic table and are usually 1 or 2 letters long. For example, the tungsten filament found inside light bulbs has the chemical symbol W. The graphite found in your pencils are made from the element carbon, which is given the symbol C. Gold, with the chemical symbol Au, can be found in lots of jewellery. Bananas, which are rich in potassium, are represented by the chemical symbol K. The same symbols are used all over the world, no matter what language is spoken. When different elements come together to form compounds, each compound is given a unique chemical formula using their symbols. We have already looked at one, H2O, which is the chemical formula for water. Another example is carbon dioxide, which is a gas we breathe out and has the chemical formula CO2. It consists of one carbon atom and 2 oxygen atoms. The small 2 after an element tells you there are 2 atoms of that particular element in each molecule. The final example is sodium carbonate, which has the formula Na2CO3. The 2 in front means that you have 2 molecules, so you multiply everything by 2 to get the number of atoms. Can you calculate how many oxygen atoms we have? We have 6 oxygen atoms. Now, let's look at how chemical reactions take place. This is when atoms of different elements are rearranged to form new compounds. Some reactions can lead to a change in colour, such as the reaction between cobalt chloride, which is normally a dark blue colour, and water. Cobalt chloride turns pink when water is added to it. This is an example of a reaction which is reversible, which means if we evaporate the water by heating up the mixture, we return to the original dark blue cobalt chloride. Throughout a reaction, the mass is always kept constant. This is given a fancy term called conservation of mass. So let's see how this works. If we take some ice and melt it into water, the mass we started off with will be the same as the mass we have at the end. If we then heat up the water into a vapor, the mass of the vapor will also remain the same as that of the ice and water. What have we learnt so far? Well, the Dalton atomic model gives a basic description of atoms. Dalton proposed that when 2 or more different atoms join, they form compounds. Atoms are the building blocks of everything in the world. Elements consist of one type of atom, whereas compounds are made of two or more different types of atoms joined together, like H2O. Each compound is given a unique chemical formula using their elemental symbol. For example, carbon dioxide is represented by the formula CO2. In any chemical reaction, the mass is always kept constant. This is known as conservation of mass and is demonstrated through the three physical states of water.